Hello. So this is my 4-bit adder, subtractor, and comparator. Now, so it is a 1-bit adder that has been converted to 4 bits. So all that is pretty much the same: carry in, sum, carry out, except this time, instead of having carry in, it is called subtraction for the entire module. Basically, if that is high, then it will go into subtraction mode. And the way that it works right here for the b variables is that when subtraction is high, it will b is attached to the subtraction mode. So if subtraction is high, then all of these b variables are XNORed with the subtraction mode. So it will basically invert those b variables and it will go into subtraction mode. And then there's also the carry wires that go from each full adder. And then here we have all of these called. But yeah, that's what this b mod equals b XNOR sub for sub is. It's the subtraction mode flipping with the use of XNORs tied to the b variable. Now, everything is the same in a 1-bit or 2-bit adder, except for these right here, this comparators. So we are assigning a greater, a lesser, and a is equal. And we have assigned these bits together as a whole, but what it does on the inside is we have the comparator module, and it assigns E and G to each bit. And it basically detects locally for each bit, is this one bit, is A greater than B, or is A equal to B, or is A less than B? That is what it's detecting. And for equality, basically it's saying an XNOR knotted. So A XNOR B, if they are the same, then they will pass as 0. And that will be knotted. Or it's an XNOR, sorry. So A is XNORed with B. So if they're the same, they'll pass a 1. And that's basically checking for each bit. If they are the same, they will pass a 1. And then this is A is greater than B over here. So it's basically taking A and B not. So if A is 1 and B is 0, it'll pass a 1. A is greater than B, it'll be high. If it is low, if A is less than B, it'll pass a 0 here. And then A lesser basically confirms this. It says is the not of A greater or equal. If either of those are 1, A lesser cannot be 1. They both have to be 0 in order for A to be lesser. So that basically is how the comparator module works, and the subtractor module works in addition to the normal full adder. The adder mode is the same as before. And then here's the test bench. We have all of these inputs registered. The subtractor mode is registered. The outputs are registered. And then here they are covered in the UUT, all being declared. I have this monitor mode. It was recommended by Claude AI, as were other things recommended by Claude AI. This mode will allow us to be able to view each of these bits independently instead of like all together. So it separates them. Sum C out is separated from A greater than B, A less than B, A equals B. That's also separate. And then all of the inputs are separate as well. So it just makes it a bit more readable. And here are our test subjects. We have 1, 0, 1, plus 1. We have 3 minus 11. We have 7 minus 6, 15 plus 14. And we're going to just go ahead and go for this one. So let's run the simulation. again. Here we have 5, 1, subtractor mode is 0. So 5 plus 1 equals 6. A is greater than. We can see that. A greater is high. A plus B, or 3 plus 11 on subtraction mode gives us 8. But we see A is lesser than, is set to high. And it'll do the same here. 7 minus 6, and subtraction mode will get 1, and we get A is greater than, which is tied to the carry out in this mode. So that'll also be high. And then also we have 15 plus 15 in both of these. And we have, in addition mode, we get E. And we get A is equal to 15 and equal to 15 in both addition and subtraction modes. And there you have that, and we're going to also open the elaborated design. Oh my goodness. Okay, here's our design finally. As you can see, this is the normal addition mode, and then we have the comparator here. And then there's also the XNOR B mod, which applies to all our B bits when we have subtraction set to high. And the subtractor always goes. And then you can see the carry wires here, going from carry in, or carry out to carry in, carry out to carry in. And then our greater, our lesser, and our equal modes.